we are still in the chapter 1, okay? So on maximum likelihood estimation, okay? So again, the procedure is the same where we have to set up our likelihood function, okay? Set up the likelihood function, which is the product of your fxi theta, okay? It depends with you have the parameter theta or parameter p or parameter lambda, okay? It depends on the distribution, okay? And then what we do is we take the ln, okay, and then differentiate with respect to that parameter. Okay, we already solved for Bernoulli distribution, Poisson distribution, and also uniform distribution, where we have the kind that this came out, your theta head is in terms of your ordered statistic. Okay. Okay. Okay, we already done this one. Okay, back to this exercise. Okay. So again, this one is a uniform distribution, but it is in the form of theta plus 1. Okay. So again, the value of the parameter theta is unknown. But before this, we already discussed about uniform distribution. Okay. But we have several cases where we have the closed interval, okay, which is 0 less than equals to y, less than or equals to theta. Okay, so this one is in terms of closed interval. So that means include from 0 up to theta. So for this case, you have the theta head is your maximum ordered statistic. Maximum ordered statistic. And then we proceed with this one. So this one is your open bracket. Open bracket. So that means your xi is just lies between 0 and theta. So in this case, your MLE does not exist. Okay, MLE does not exist because we cannot find any theta that fit this dia punya likelihood function. Okay, so the possible value to it can be anything. Okay, on the line because it does not include. It cannot be greater than each observed value. That means theta is greater than xi. So it can be any kind of value because we don't have any equality, which is theta greater than or equals to xi. So that is the case for open bracket 0 and theta. Okay. So for this one, okay. So if we have your range from theta up to theta plus 1, so actually we have here, okay, we have here is just, so example, your theta less than x less than theta plus 1. So when we want to describe our distribution, okay, our distribution, okay, sorry ini, saya buat close bracket theta plus 1. Okay, so it should have theta less than or equals. Okay, so in this case, so since this one is a uniform distribution, so general formula for uniform distribution, you will have fx, okay, for example, 1 over b minus a. If your a, it can be less than or equal, so it's depend on your interval. So when we have uniform distribution, so that's mean 1 over b minus a. So in this case, if we have a uniform distribution, so that means your fx will become 1 over, so your b is theta plus 1, your a is theta, so it becomes 1, okay? Where your theta is less than or equals to x, less than or equals to theta plus 1, okay, 0 otherwise. So this is uniform distribution for case when you have theta plus 1, maksudnya punya range tu. Okay, sebab dia punya general formula is this one. So that's mean we just substitute 1 over b minus a. So in this case, we will have 1. So kalau kita build up dia punya likelihood function pun, is still the same lah. Kita ada L, theta. So 1, 1, 1. So again, macam tu je lah. 1 to power n. Okay. So selain tu, kita ada 0 lah. The same range. Okay. So in this case, okay, because kita tengok dekat dia punya range dia, So we have two alternative value. Okay. So the smallest value, okay, if we consider theta less than or equals to x, so it can be x greater than or equals to theta. Satu lagi kita consider x less than or equals to theta plus 1. Okay, the smallest value, xi. Okay, katakan xi must be greater than or equals to theta. So, kalau kita susun in terms of ordered statistics, kalau kita differentiate, ambil ln and so on, kita tidak memberi apa-apa maksud. Okay, so the question, not the question, the answer is it should be, your theta h should be ordered statistic. But in this case, we have two alternative. Okay, either your xi is greater or equals to theta, or your xi is less than or equals to theta plus 1. Okay, so kalau let's say if we have this one, yeah, so katakan ini x greater than or equals to theta. So kalau kita biasanya kita susun, kita ada x1, ordered statistik kita x2, sampailah kita ada xn. Okay, so ini kita punya theta, ini theta plus 1. So in this case, so let's say we have theta less than or equals to x1. So our value of our first theta head, okay, is the minimum ordered statistic, okay, which is your theta, okay lah, sini lah, mean of x1, x2, xn, okay, which is your theta less than or equals to first ordered statistic. Okay, and then the other one, okay, kita ada Sn less than or equals to theta plus 1. Okay, so ini saya tulis kat sini. Okay, so that's mean your theta greater than or equals Xn minus 1. Okay. Okay, Xn minus 1. So, bila kita tulis Xn less or equals to theta plus 1, so you need to find your theta. So, theta is greater than or equals to Sn minus 1. So, it can be, kalau kita susun balik, so that's mean Xn, your maximum ordered statistic, less or equals to theta, less or equals to first ordered statistic. Okay, so you have two possible answer. Either your theta, your maximum ordered statistic minus 1, ataupun satu lagi kita ada minimum ordered statistic. So for this kind of solution, normally what we write is MLE in this case is not unique. Okay, sebab kita ada two possible, sama ada it should be maximum ordered statistic minus 1 ataupun your theta head is less than or equals to your first ordered statistic. So in this case, your MLE is not unique. Okay. Kalau yang tadi, lah. Okay, this one kita ada open bracket. Okay, kita tak ada equality signs. Okay, so in this case, your MLE does not exist. Okay, but this one, we have we consider we have two values of theta. Okay, either theta ataupun theta plus 1. Okay, so it should be either first order statistic ataupun maximum order statistic minus 1. So in this case, kalau kita draw pun dia punya likelihood function, so katakan di sini. Okay, so katakan ini kamu punya apa? L theta lah Okay, likelihood function dia. So kamu ada 1 je. Okay, tadi kita ada. Okay. Percaya. Okay, ini maximum ordered statistic. Katakan ini first ordered statistic. Macam tu. Punya line tu lah So it can be any value in the interval. Okay. So that's why in this case, your MLE is not unique. Okay. For this kind of distribution. Bila kita ada closed interval, you have two possible values of theta. Okay. It's different daripada yang sebelum tu. Yang tadi, yang first, kita ada uniform distribution macam biasa. Okay. So it can be either no lah. Okay, this one should be maximum order statistic. It depend on the range. Satu lagi, if we have open bracket. Okay, open bracket. That's mean in this case your MLE does not exist. Any closed interval, but again, any kind of data that fits that one. Okay. So kalau kita susun tadi, kita ada maximum order dengan first order statistic. So in this case, the MLE is not unique. MLE does exist, tapi cuma is not unique. Okay. So itu kau punya answer lah ya. Solution how you want to solve this one. Okay, sebab ini kita macam discussion je. Discussion on that kind of parameter data. Okay. Ada apa-apa soalan ke for this one sebelum saya... Ini saya dah discusskan, right? Okay, so again the same thing lah. Okay, kamu dah ada MLE for 2 parameter. So dapatkan parameter mu head and so on. Okay, ada apa-apa soalan ke this one? Okay, kita proceed the next one lah. If you don't have any question for this one. Okay, the exercise that I give you. Okay, boleh nampak eh? Boleh. Okay, so this kind you have a gamma distribution. Kita cuba try ke? Dah cuba try. Okay, dah try ke these questions? Okay, so first you need to write what is your gamma distribution. So ini taburan gamma gamma. Gamma kita ada 2 parameter. Okay. If you refer back to the previous last lecture tu, saya minta kamu susun, tulis setiap distribution dia, apa dia punya density function. So itu memudahkan kita lah ya. So bila kita ada this kind of distribution, kamu just refer to that your list of formula of distribution. Okay, this one you have alpha equals to 3, beta kita setkan sebagai theta. Okay, so that's mean dalam case ni yang unknown parameter dia adalah this one. Okay, because alpha is already given. Equals to 3. So alpha in this case is your known parameter. So first you write down what is your general formula for gamma distribution. So this one is gamma distribution. Okay. For gamma distribution, okay, you will have, so kita ada katakan parameter dia alpha and beta. Okay. So this is the standard density function. Gamma is a continuous, gamma alpha, beta alpha, x alpha minus 1, exponential, negative x over beta. So ini kamu punya standard density function. Okay. So now kita replace dulu. Kita replace alpha equals to 3, beta is equals to theta. So again, okay, so katakan sekarang kita ada beta je lah So gantikan, okay, gamma 3. So beta, you have theta over alpha. So this one. So x alpha minus 1. So x square, exponential negative x over theta. Okay, so sekarang kita build upkan dia punya likelihood function. Build upkan dia punya likelihood function. Okay, so likelihood function is a product of your fxi, beta lah dalam kes ni. So just write down your L. Okay, beta. Okay, kalau nak tulis ini pun, sorry. Bukan beta dah lah sebab kita dah define kita punya parameter tu sebagai theta. Okay, so you have here is L. Sorry, ini pun atas tu pun you ganti balik eh. Okay, L theta X. So kita adalah product, okay, product of your likelihood function, which is your I equals to 1 up to N, F xi, okay. Okay, Fsi theta. So again, bila kita dah gantikan alpha equals to 3, so that means gamma 3 tu is a constant. Dia bukan lagi in terms of a function of your parameter. It's just a constant. Okay. So again, you will have 1 over gamma 3 theta cube. Okay, kita ada n times. Maksudnya kita repeat benda tu, step satu. Right? So you have n times. So kalau tak pasti, expand dulu. Maksud saya buat fx1 theta, multiply fx2 theta, sampai kamu ada fxn theta. Okay, so you will have this form. 1 over gamma 3 theta cube, okay, bracket to the power n. Okay, ini product. So x1 square, x2 square, xn square. So what we have here is just a product of your xi and then square. Ataupun xi square macam ni pun boleh lah kalau let's say tak letak bracket pun. It's the same thing je. Okay, product xi square. And then kita ada exponential negative x over theta. So exponential negative x1 theta, exponential negative x2 theta, exponential negative xn theta. So what you have here is just exponential negative summation xi over theta. Okay, make sure you can write this likelihood function. Okay, maksudnya kamu masukkan satu-satu. So 1 over gamma 3 theta cube. So we have n times. So bracket semua to the power n lah. Okay, x1 square, x2 square. So product si square. Exponential negative x1 theta. Exponential negative x2 theta. So we will have here is just summation. Exponential negative summation si over theta. Okay, so that is your likelihood. Okay, and then take ln. Dapatkan dia punya ln dia. Okay, ambil ln. So ln L theta. Okay. So you have n ln 1 which is 0. So I didn't write that. So you have negative n ln gamma 3. Okay. Then you will have 3n ln theta. Okay, saya split 1 over gamma 3 to the power n. 1 over theta cube to the power n. So bawa ln, ambil ln. So you have this one. And then plus ln of your product xi square minus summation xi over theta. Okay, dapat tak that? Boleh follow kat sini. Ln L theta ni. Okay. Okay, now kamu differentiate. Okay, differentiate cuba bagi saya apa nilai theta head yang kamu dapat. Differentiate with respect to theta and then set equal to 0. Dapat apa tu? So, kita differentiate yang ada parameter theta saja. So, if you differentiate here, okay, so kita ada negative 3n ln theta. So, differentiate, you will have negative 3n over theta, right? Okay, satu lagi kita ada minus summation si over theta. So, differentiate this one, theta bawa ke atas, so theta to power minus 1. So, differentiate kan, you will have plus summation xi over theta square. Set kan equal to 0. Okay, bagi saya apa dia punya nilai theta head?
Satu per 3 X bar ke?
Betul?
Okay.
Okay. So, you will have your theta head here. Okay. So, selesaikanlah. Kayaknya bagi dia punya apa? Denominator dia sama. So, you have theta. So, you have negative 3n theta plus sama macam SI. So, bawa sebelah kiri kanan semua tu. So, selesaikan. You just write here is your theta head is just, saya tulis sini je dah. X bar divided by 3 ya. Okay, so that one. Nampak sebenarnya X bar X bar over 3. So, that is your theta head. Okay. Cuma, okay, di sini, okay, careless mistake yang biasa berlaku kat sini. Masa kamu nak set up kamu punya likelihood function ni. So, bila likelihood function kamu punya kuasa ke apa ke dah tersalah, dia akan affect ln kamu. So, of course, dia akan affect terus kamu punya theta head. So, make sure you understand how I get here. Macam mana kita dapat? Sebab kita punya produk here, 1 over gamma 3 tu constant. Sebab dia punya tu value je. Theta 3 to the power n. Sebab kita repeat sampai kita ada xn. So, that's why kita start dengan ini. Random sample. So, setiap satu tu x1 dia gamma distribution. x2 pun gamma distribution. So, of course, you have n gamma distribution. Okay? So, again, this one, you will have product xi square. Okay, tapi ini tak ada effect sangat sebab dia tak ada parameter theta tu. Okay? So, yang ada theta tu, yang ada parameter tu is concern. Very concern bila kamu nak differentiate and so on. So, exponential negative summation si over theta. So, differentiate kan. Ambil ln. Ambil ln. And then baru kamu differentiatekan respect to theta. Okay, and then you get lah theta head is equals to x bar over 3. Okay, so untuk gamma distribution, okay, kalau let's say unknown parameter okay, dia ada dua choice juga lah. Ini kalau salah satunya non parameter. Non parameter maksudnya diberi nilai alpha equals to 3. Okay, yang unknown dia beta equals to theta. So, for certain case, ada juga yang unknown parameternya alpha. Tapi non parameternya beta. Okay, cuma kamu kena tahulah apa general formula ni. General formula ni kamu substitute. Substitute dulu, lepas tu baru ambil likelihood function and then get the product and then ln differentiate. Okay, so for third case dia, bila both unknown parameters. So, kalau dua-dua unknown parameters, maksudnya alpha pun tak tahu, beta pun tak tahu, kita perlu estimate alpha head, perlu estimate beta head. So, normally inilah yang saya cakap, kita buat coding, algorithm, programming, and then kita iterate kan, okay, iterate sampai di-converge ke satu nilai. Biasanya kita akan guna kaedah trial and error lah, kaedah cuba jaya. Masukkan beberapa value and then kalau di-converge ke that value, so that is your MLE. Okay. Biasa ini kita pakai programming. Okay. Untuk estimate dia punya unknown parameter. Okay. Tapi kalau dalam soalan untuk test ke apa, salah satu tu adalah unknown parameter lah. Kalau ini memang kamu tak boleh nak solve. Kamu kena solve iteratively guna programming. Kalau for project, assignment ke apa, it's okay. Okay. So that one. Boleh So, the same thing juga kalau let's say beta distribution. Saya minta juga kamu tulis apa density function for beta. So, it can be either one. Salah satu tu is a known parameter. Then you can solve lah. Okay. So, satu lagi. Sekejap ya. saya nak kamu mahir juga untuk gamma distribution So kalau okay, refer pada buku lah So kamu kena tahu gamma alpha sebenarnya adalah alpha minus 1 factorial. Benda-benda macam ni kena tahu. Sebab kita kalau let's say katakan gamma 3 macam ni kan. Kalau ada density function lah Gamma 3 ni instead of kamu pakai gamma 3, kamu boleh tukar juga kepada bentuk factorial. So dia akan jadi 2 minus 1 factorial. 3 minus 1. So tinggal 2 factorial lah. So maksudnya kita akan tulis 1 over square je. 1 over 2. Okay. Benda tu pun you need to know lah apa dia punya density function, apa maksud gamma alpha ni. Okay. So ini memang tak ada dalam nota saya, cuma ini extra work for you lah. Okay, tengok buku. Cari buku. Okay, buku inferential tu memang ada. Kalau gamma alpha maksudnya adalah alpha minus 1 factorial. Okay. Itulah. And then katakan kalau beta kita ada ini gamma alpha plus beta. So katakan beta tu kita letakkan alpha plus 2. Okay, still gamma function. Tapi dia akan jadi alpha plus 2, kau masuk sini, minus 1 factorial. So dia akan jadi alpha plus 1 factorial. So alpha plus 1 factorial ataupun kita boleh expand juga alpha plus 1. Kan dia and then alpha factorial semua tu. Kan kalau macam kamu ada nak cakap okay 4 factorial lah. Okay, 4 factorial maksudnya 4 sama kan? Macam tu, right? It's the same thing. Okay, kalau kita nak splitkan dia untuk memudahkan kita punya calculation ataupun kita punya cancel out ke, kita dah ada dia punya term yang sama, so nak cancel out, it's the same thing. So itu kena aware, okay, dia punya konsep factorial and so on lah, benda yang kamu boleh. Okay, so ini pun macam basic matematik juga lah benda ni. Okay, so ada apa persoalan ke for this one, gamma ni? Okay, kita tengok the next one.